The discovery of Gliese 504b isn't just a standalone wonder, it's a puzzle piece in the grand picture of planetary formation. The idea that such a massive planet could exist so far from its parent star challenges the core accretion model, which has long been the leading theory. In this model, a dense core forms first, gathering gas and dust around it to grow into a massive planet. This process is expected to occur closer to stars, where materials are denser. But with Gliese 504b residing in the cosmic outskirts, scientists are considering an alternative, disk instability. This theory suggests that planets can form rapidly when large portions of a protoplanetary disk collapse under their own gravity. This process could explain why Gliese 504b exists so far from its star. If disk instability turns out to be a more common mechanism than previously thought, it might redefine how we think about the formation of gas giants and even smaller planets. While the planet's magenta hue is visually stunning, it's also a vital clue about its age and temperature. Most gas giants we observe appear dull brown or gray, often due to the cooling of their atmospheres over billions of years. However, Gliese 504b's young age, just 160 million years, means it still radiates heat left over from its formation. This heat affects the atmospheric chemistry, potentially creating exotic compounds not seen on older gas giants. Scientists are now delving into its atmosphere to determine if other unexpected elements or reactions are taking place. If such phenomena are confirmed, they could help us better understand the evolution of planetary atmospheres. The exploration of exoplanetary weather systems is turning science fiction into fact. On planets like WASP 76b, where it rains molten iron, and HD 189733b, with winds that blow sideways at 5,400 miles per hour, weather defies anything we experience on Earth. These hostile environments push the boundaries of our understanding of planetary physics and chemistry. Scientists are especially intrigued by Gliese 504b's potential auroras. These phenomena are likely driven by its strong magnetic field, which is possibly bolstered by interactions with nearby moons or companion planets. By studying auroras on such distant worlds, researchers can refine models of magnetic field generation and dynamics, insights that could even shed light on Earth's own magnetic field history. Webb's ability to probe atmospheres is revolutionizing exoplanet studies. Gliese 504b's methane-rich atmosphere, combined with water vapor, offers clues about its chemical makeup and thermal history. But why stop at one planet? With the discovery of thousands of exoplanets, each one adds a unique chapter to the story of planetary science. For instance, WASP 12b teaches us about tidal forces as it's slowly being consumed by its star. TOIS 700d, an Earth-sized exoplanet in its star's habitable zone, could harbor conditions ripe for life. LTT 9779b, the space mirror, reflects so much starlight that it forces scientists to rethink atmospheric compositions. By comparing Gliese 504b to these diverse worlds, scientists can refine their theories about planet formation, migration, and the range of possible planetary environments. Although Gliese 504b isn't a candidate for hosting life, it still plays a role in answering the age-old question, are we alone? The more we learn about planets like it, the better we understand the conditions that make life possible, or improbable. For instance, a planet's magnetic field can protect it from harmful cosmic radiation, a prerequisite for sustaining life. Gliese 504b's auroras suggest a strong magnetic field, sparking new questions about whether such fields could exist on smaller, potentially habitable planets. Could this lead to the discovery of Earth-like planets with enhanced protections? The possibilities are exhilarating. Each discovery, from Gliese 504b to the auroras on gas giants and the iron rain of WASP 76b, underscores how diverse and unpredictable the cosmos truly is. These findings challenge us to expand our understanding of what's possible, not just in planetary science but in the fundamental rules of nature. The universe is full of mysteries waiting to be solved, and every new planet Webb discovers is another piece of the cosmic puzzle. Could some of these pieces hint at other forms of life, other civilizations, or even new physical laws we have yet to uncover? Opening hook, the universe is full of mysteries, and today we're diving into one of its most stunning revelations, a magenta planet unlike anything we've ever seen. Meet Gliese 54b, a planet that's rewriting the rules of planetary science. Why it matters: highlight the importance of discoveries like Gliese 54b and challenging our understanding of planet formation and the universe. Visual and emotional appeal: describe its vibrant magenta hue, and how it stands out. Age and formation: introduce its youth in cosmic terms, 160 million years, and how its color might be linked to leftover heat from formation. Orbital oddities: discuss its surprising distance from its star and the implications for planetary formation theories. Formation theories: explain the traditional core accretion model versus disk instability and why Gliese 54b challenges these norms. Scientific breakthroughs: how the James Webb Space Telescope, JWST, enables such discoveries, cutting through stellar glare with its infrared capabilities. The James Webb Telescope is just the beginning. NASA's upcoming Habitable Worlds Observatory and the European Space Agency's Ariel mission will take planetary studies even further. These instruments will focus on direct imaging of Earth-like planets and the detailed analysis of atmospheric components, potentially answering some of the biggest questions about life in the universe. Meanwhile, ground-based observatories like the Extremely Large Telescope, ELT, in Chile will complement Webb's work, offering unparalleled resolution for studying exoplanets. Together, these tools will help scientists map out the chemical and physical diversity of planets across the Milky Way. Kindly like, share and subscribe our channel for further more update about space.